Visit parthakachana.com for technology resources and stock analysis. 50 advanced level DevOps and cloud computing interview questions with corresponding answers. 1. How do you design a highly available, scalable, and secure cloud architecture? Answer. Highly available and scalable architectures use multi-region or multi-availability zone deployments with load balancers, auto-scaling groups, redundancy, and failover mechanisms. Security is enhanced by leveraging IAM roles, security groups, network ACLs, encryption, at rest and in transit, and VPNs for private connections. 2. What is blue-green deployment, and how does it ensure zero downtime? Answer. Blue-green deployment involves maintaining two identical environments, one active, blue, and one idle, green. New code is deployed to the green environment. Once tested, traffic is routed to the green environment, minimizing downtime and ensuring rollback options. 3. Explain how you would manage large-scale infrastructure as code, IAC, in a multi-cloud environment. Answer. Managing large-scale IAC in a multi-cloud environment can be done using tools like Terraform, which provides cloud-agnostic templates. Version control systems like Git ensure consistency, and modular design principles help with reusability. CI/CD pipelines ensure the automation of deployments. 4. How does Kubernetes handle service discovery and load balancing? Answer. Kubernetes uses a service abstraction to expose pods to other services or external clients. It provides built-in service discovery via DNS and performs load balancing across the pod replicas, distributing traffic based on round-robin or other strategies. 5. What are chaos engineering and its importance in cloud infrastructure? Answer. Chaos engineering involves intentionally injecting failures into a system to test its resilience. It helps ensure that cloud systems can withstand unexpected outages, network failures, and resource exhaustion while maintaining performance. 6. How do you implement canary releases in a CI/CD pipeline? Answer. Canary releases gradually roll out new features to a small subset of users while monitoring performance and error rates. CI/CD tools like Jenkins, Spinnaker, or GitLab CI can be integrated with Kubernetes or AWS Lambda to manage the gradual deployment. 7. What strategies would you use to optimize storage costs in the cloud? Answer. Storage cost optimization includes using lower-cost storage classes, e.g., AWS S3 Glacier for infrequent access, enabling lifecycle policies to automatically transition or delete data, compressing data, deduplication, and managing snapshots effectively. 8. How does a service mesh like Istio improve microservice communication? Answer. Istio provides features like service discovery, load balancing, failure recovery, and monitoring. It handles secure communication between microservices using mutual TLS, and it enforces policies such as rate limiting and circuit breaking. 9. What is autoscaling, and how does it work in Kubernetes? Answer. Autoscaling in Kubernetes adjusts the number of pod replicas based on resource usage, e.g., CPU or memory, using the horizontal pod autoscaler. It monitors the application and automatically scales up or down to meet demand. 10. How would you secure a CI/CD pipeline? Answer. Securing a CI/CD pipeline includes ensuring that code repositories are protected with access control, scanning for vulnerabilities and dependencies, using secrets management, e.g., Vault, applying signed artifacts for integrity, and enforcing least privilege access across the pipeline. 11. What is a service level objective, SLO, and how do you define one for a critical application? Answer. An SLO is a target value or range of values for a service's performance or availability, such as 99.9% uptime. It is defined by analyzing user requirements, business goals, and the cost of downtime, often tied to SLAs. 12. How does Kubernetes handle persistent storage? Answer. Kubernetes uses persistent volumes, PVs, and persistent volume claims, PVCs, to abstract storage from containers. Storage classes define the types of storage, e.g., AWS EBS, Google Persistent Disk, allowing dynamic provisioning. 13. How do you approach cloud resource cost monitoring and optimization at scale? Answer. Cloud cost monitoring is achieved through tools like AWS Cost Explorer, Google Cloud Cost Management, or third-party solutions like Cloud Health. Cost optimization involves right-sizing resources, implementing auto-scaling, terminating idle resources, and selecting the appropriate pricing models, e.g., reserved instances. 14. What is GitOps, and how does it differ from traditional DevOps practices? Answer. GitOps is a methodology where Git is the source of truth for infrastructure and application deployments. All changes are version controlled and automatically deployed using IAC tools. It contrasts with traditional DevOps by emphasizing declarative infrastructure and fully automating deployments via Git. 15. Explain the role of serverless architecture in cloud computing. Answer. Serverless architecture allows developers to run applications without managing underlying infrastructure. Services like AWS Lambda, Azure Functions, and Google Cloud Functions automatically scale based on demand, reducing the need for provisioning and paying only for execution time. 16. How does Terraform handle state, and what are the risks of state management? Answer. Terraform uses state files to track resources it manages. These state files are critical for operations like updates and deletes. Poor state management can lead to resource drift, making environments inconsistent. Best practices include remote state storage, e.g., S3 with locking mechanisms and versioning. 17. What are the key differences between Docker Swarm and Kubernetes? Answer. Docker Swarm is simpler, easier to set up, and integrates natively with Docker. Kubernetes offers more advanced features like auto-scaling, self-healing, and rolling updates. Kubernetes also has a larger ecosystem and is better suited for complex, large-scale deployments. 18. How do you design and manage a multi-region failover strategy? Answer. A multi-region failover strategy involves deploying infrastructure in multiple regions with health checks and failover mechanisms, e.g., Route 53 for DNS failover in AWS. Active-active or active-passive setups ensure redundancy, and databases must use replication mechanisms across regions. 19. What is the importance of observability in cloud-native environments? Answer. Observability includes logging, monitoring, and tracing, allowing teams to understand the internal states of applications. It provides real-time insights into system performance, helping identify issues like latency, errors, and bottlenecks in distributed cloud-native environments. 20. How do you ensure security in a multi-cloud environment? Answer. Multi-cloud security involves using cloud-agnostic IAM policies, unified logging and monitoring, data encryption, secure inter-cloud communication, e.g., VPNs, and ensuring compliance with regulatory requirements across all cloud providers. 21. Explain the role of sidecar containers in Kubernetes. Answer. Sidecar containers run alongside the main application container in the same pod, providing auxiliary services like logging, monitoring, or proxying traffic. They allow separation of concerns by decoupling application logic from infrastructure concerns. 22. What is the purpose of cloud-native disaster recovery, and how would you implement it? Answer. Cloud-native disaster recovery ensures business continuity in case of failures. Implementation involves creating backups, cross-region replication, defining RPO/RTO objectives, and using services like AWS Elastic Disaster Recovery for quick recovery of critical systems. 23. How do you manage patching and upgrades for a large-scale Kubernetes cluster? Answer. Patching and upgrades are managed using rolling updates to avoid downtime. Kubernetes itself can be upgraded via tools like Kubeam or managed services like GKE, EKS, or AKS. Automated pipelines should test and apply patches incrementally to minimize risk. 24. What is the importance of configuration as code in a DevOps environment? Answer. Configuration as code, CAC, ensures that configurations are treated as version-controlled, immutable artifacts. It promotes consistency, repeatability, and automated recovery, and is often implemented alongside IAC using tools like Ansible, Chef, or Puppet. 25. How does Kubernetes implement security for interpod communication? Answer. Kubernetes secures interpod communication using network policies, which define which pods can communicate with each other. TLS is often implemented for encryption, and tools like Istio provide additional security layers, including MTLS for mutual authentication. 26. How does AWS CloudFormation differ from Terraform? Answer. CloudFormation is AWS-specific and provides native support for managing AWS resources as IAC. Terraform, on the other hand, is multi-cloud and allows for infrastructure provisioning across multiple providers with a more extensive module ecosystem. 27. What strategies do you use for managing multi-environment deployments, e.g., dev, staging, prod? Answer. Multi-environment deployments are managed using separate configuration files, namespaces, or branches in version control. Tools like Helm in Kubernetes or parameterized Terraform modules allow for consistent deployments across environments. 28. How would you set up CI/CD for a microservices architecture? Answer. CI/CD for microservices involves building and testing each microservice independently, deploying them to container registries, e.g., Docker Hub, and using orchestrators like Kubernetes to deploy and manage them. Canary deployments or feature toggles enable safe, incremental updates. 29. What is the difference between immutable and mutable infrastructure? Answer. Immutable infrastructure means that once a server or environment is deployed, it is never modified in place. Instead, new servers are built and deployed with changes. Mutable infrastructure, on the other hand, allows updates and changes directly to running servers, which can lead to configuration drift. 30. How do you monitor cloud infrastructure for anomalies or threats? Answer. Anomaly and threat monitoring in the cloud is done using tools like AWS CloudWatch, Google Stackdriver, or third-party solutions like Datadog. Security event detection can be enhanced with intrusion detection systems, IDS, or SIEM tools for real-time threat alerts. 31. How do you manage secrets and sensitive data in a cloud environment? Answer. Secrets and sensitive data can be managed using services like AWS Secrets Manager, Azure Key Vault, or HashiCorp Vault. These tools encrypt the data at rest and in transit, provide access controls, and rotate secrets periodically for enhanced security. 32. What is the CAP theorem, and how does it apply to cloud-native applications? Answer. The CAP theorem states that in a distributed system, you can only achieve 2 out of the 3: consistency, availability, and partition tolerance. Cloud-native applications often sacrifice strong consistency for high availability and partition tolerance to ensure scalability across regions. 33. How do you implement centralized logging in a Kubernetes cluster? Answer. Centralized logging in Kubernetes can be implemented using tools like Fluent, Elasticsearch, and Kibana, the EFK stack, or Loki and Grafana. These tools aggregate logs from all nodes and pods, making them accessible for real-time monitoring and troubleshooting. 34. How do you approach container security in a production environment? Answer. Container security involves scanning images for vulnerabilities, using tools like Claire or Trivy, enforcing policies with admission controllers, isolating containers with namespaces and corrupts, using minimal base images, and managing secrets securely with tools like Vault. 35. How would you handle data consistency across microservices? Answer. Data consistency across microservices can be managed using eventual consistency patterns, such as event sourcing or the Saga pattern. Transactions are broken into smaller, manageable steps that are independently verified and committed across services. 36. What are custom resource definitions, CRDs, in Kubernetes, and when would you use them? Answer. CRDs allow users to define their own resource types in Kubernetes. They are used to extend the Kubernetes API, enabling custom controllers to manage non-native resources, e.g., a custom operator for a specific application lifecycle management. 37. How do you manage cloud costs in a dynamic, auto-scaling environment? Answer. Cloud cost management in an auto-scaling environment involves setting up budgets, right-sizing instances, and configuring auto-scaling groups to efficiently manage resources. Tools like AWS Cost Explorer or Google Cloud Billing can help monitor and optimize costs based on real usage. 38. How do you implement rate limiting in cloud-native applications? Answer. Rate limiting can be implemented using API gateways, e.g., AWS API Gateway, Kong, or Istio, or at the application level with libraries that track request counts. Rate limiting ensures that users or services do not overwhelm your system. 39. What is container orchestration and why is it important in DevOps? Answer. Container orchestration is the automated deployment, scaling, and management of containerized applications. Tools like Kubernetes, Docker Swarm, and Nomad provide these capabilities, making it easier to manage large-scale, distributed container environments. 40. How would you set up and manage disaster recovery for a cloud-native application? Answer. Disaster recovery involves setting up backups, replication across regions, and defining recovery time objectives, RTO, and recovery point objectives, RPO. Tools like AWS Elastic Disaster Recovery or Google Cloud Snapshots automate recovery processes in case of a failure. 41. What is the importance of a service catalog in cloud environments? Answer. A service catalog provides a central repository of cloud services that are available for use in an organization. It promotes governance, ensures consistency, and accelerates development by providing pre-approved services with compliance and security standards. 42. How does Kubernetes handle resource quotas and limits? Answer. Kubernetes allows administrators to set resource quotas at the namespace level, ensuring that no single team or application consumes excessive resources. Limits can be set for CPU and memory at the pod level to prevent resource exhaustion. 43. How do you handle stateful applications in Kubernetes? Answer. Stateful applications can be managed in Kubernetes using stateful sets, which ensure the proper ordering and stable identity of pods. Persistent volumes, PVs, and persistent volume claims, PVCs, are used to manage the storage needs of stateful applications. 44. What is the difference between vertical and horizontal scaling in cloud environments? Answer. Vertical scaling involves increasing the resources, e.g., CPU, memory, of a single instance, while horizontal scaling adds more instances to distribute the load. Horizontal scaling is often preferred in cloud environments for better redundancy and fault tolerance. 45. How would you implement monitoring and alerting in a multi-cloud environment? Answer. Monitoring and alerting in a multi-cloud environment can be achieved using centralized solutions like Prometheus and Grafana or cloud-agnostic services like Datadog or New Relic. Alerts are configured based on predefined thresholds to notify administrators of issues. 46. What is the role of service discovery in microservices architecture? Answer. Service discovery allows microservices to dynamically locate each other without hard-coding IP addresses. Tools like Consul, Kubernetes DNS, or Eureka provide this functionality, making it easier to manage services in dynamic environments. 47. How do you manage versioning of microservices in a CI/CD pipeline? Answer. Microservices versioning is managed using semantic versioning, e.g., version 1.0.0. CI/CD pipelines are configured to automatically tag and deploy new versions of microservices based on code changes. Canary releases or blue-green deployments can be used to minimize risk. 48. How do you handle database migrations in a DevOps pipeline? Answer. Database migrations in DevOps pipelines are handled using tools like Flyway or Liquibase. The migrations are version-controlled and applied in an automated manner during the deployment process, ensuring consistency across environments. 49. What are some strategies for optimizing container performance? Answer. Optimizing container performance involves minimizing the size of container images, using efficient resource allocations, CPU and memory, reducing the number of layers in Docker images, and ensuring proper caching mechanisms are in place. 50. How do you ensure high availability in a cloud-native database? Answer: high availability for cloud-native databases is achieved using replication, e.g., multi-AZ deployments, automatic failover, and backup strategies. Managed services like Amazon RDS or Google Cloud SQL offer built-in mechanisms for ensuring availability. Thank you for watching. Like, share, and subscribe. Visit parthakachana.com for technology resources and stock analysis.